Oh, well, thank you, Lauren. Lauren just said she liked math. Lauren, would you like to tell YouTube world anything else? Oh, she just hit me. Did you? There was contact, wasn't it? She hit me with her hand. Oh, wow. BC covers more topics. We take AB. Say that, but that's where it is. So you can see that summation, a little introduction for you. So today what we'd like to do is we'd like to take, when you add those sequence numbers up, it becomes a series. And so today we want to look at series, and we represent series in summation notation. So this is it's not an E. This is a sigma, and it means sum. So it's the capital letter for S in Greek. The lowercase letters for S or sigma look like that. This is a sigma if it's in the middle of a word. This is the sigma if it's at the end of a word. Those are lowercase. It wasn't until later that they had the uppercase. So you're going to have a rule that's going to define the sequence right here. And this is going to be your first term defined, and this will be your last term defined. So it says expand the following summations. As soon as you see sigma, you have to say, okay, I'm going to write it as a sum. That's what it means. So for this series, we begin with 2, and 3 times 2 is plus 1 is, so the first term is 7. After 2, what do you think we plug in? 3. And you get 3 times 3 is 9, plus 1 is 10, and then you plug in, you get 13, and then you plug in 4 or 5, and you get. So you can see that this is the expanded form of the summation notation. You start with 2, you end with 5, a total of 4 terms. Yes, Jake from State Farm. That's the last one that we plug in. So 3 times 5 is 15, plus 1 is 16. We good? Does anybody else have a question before I go on? Yes. Okay, so you could think of it as an integer. Our term numbers will always be an integer. We start with the integer 2, and we go up to the integer 5. That's what you plug in for n. That is your integer number that you plug in for n. But if we said n is 2, then that would be like n is always 2, and that's not the case. Okay. All right, let's look at letter B. We start with 1. 4 to the 1 minus 1. 4 to the 0, which is 1 times 2 is 2. Plus, what do I plug in next? And I get 4 to the 1 is 4 times 2 is 8. And then I plug in 3. I get 32. Only 3 terms there. It's expanded form. These mean the same thing. Let's look at this one. Sum from I equals 1 to 100 of 2 minus 5n. What would be your first term? Negative 3. Then you plug in 2, and you get negative 8. Then you plug in 3, and you get. Now, after you generate about 3 terms, you don't write it out all the way to 100. You can just write plus dot, 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 and then just include the very last term so they know when you end. So if we were to plug in 100, you get 2 minus 500, which is negative 498. That'll be fine as well. Yes. What would you like to write instead? Oh, no, 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 no. The sigma means sum. Okay. No, it's okay. All right. For D, I plug in 3. As you plug in 3, 3 minus 1 is, so 4, and then negative 1 to the third is, so we get negative 4. What What do I plug in next? 4. And 2 to the third is 8. Positive 8. Then I'll plug in 5. You can see that it's going to switch back and forth between positive and negative, correct? Yeah. And then we go all the way up to, if we plug in 20, is the -1 going to end up being positive or negative? Positive because it's an even power, and then 2 to the 19th. So there we have it. You can write 2 to the 19th. You don't have to write the actual number out. So the cool thing about summations is being able to come up with the actual sum. And so if we have a partial sum of an arithmetic series, like we saw with Gauss, we could say that the sum through n terms is equal to, let's think about what Gauss did. He took 1 and added it to 100. So he took the first term and he added it to the last term. And then he multiplied that by how many? 1 plus 100 times 50. Why 50? Half of n. So he took half of n. And so the formula for the partial sums of arithmetic series is n times first term plus the last term all divided by 2. So let's generate some terms and then add it up. You can see if you plug in 1 here, you get 4. If you plug in 2, you get 7, 10, all the way up to 61. So the question is, what is the sum of the first 20 terms of that sequence? We take n times, well, what is n in this problem? It is 20 times, yep, the first term is 4, the second term is 61, or the last term is 61, all divided by 2. What is 20 divided by 2? And 61 plus 4 is 65. So as B. Rodden said, 650. When I saw sequences in series, that was one point in my life where I said, yeah, I for sure want to be a math major. Well, this is one of those pieces. Mathematical induction was another. A lot of things are very cool. Don't make fun of my major. I won't make fun of yours. No, it's okay, Ella. You can make fun of me all you want. So, all right. All right. First term will be 96. Second term? What will the 15th term be? 40. So the sum of the first 15 terms is equal to the number of terms, the first term, the last term, all divided by 2. 96 plus 40 is 136. Divided by 2 is 68. So we have 15 times 68. And we'll do our old-fashioned multiplication. $1,020. What do you think about that? Let's do 2 more, then we'll go to geometric series, and then we'll go to infinite series. Infinite is super awesome. We'll do a proof for B. Rodden. You guys have done so many proofs this year, and you don't even know it. Okay, so the sum of the first n terms is n times -8 plus 58 divided by 2. -8 plus 58 divided by 2. So what's wrong with this problem? I don't know what n is. How could we figure out n? How will you solve for it? Mr. Ware, what'd you say? Okay, Jake's along the right line. He says he would like to use a sub n is equal to a sub 1 plus the difference times n minus 1. He'd like to write a rule for it, figure it out. That is essentially what you're coming up with, and I'll show you why you were coming up with that. Our last term is what? 58. And he said 58 equals, and then he said negative 8. What is the difference? 3. And he said n, but he did not have the minus 1. But he was trying to think of a rule. Well, we know how to come up with a rule for an arithmetic sequence. It's right there. That's all we do. Can we solve for n now? Yeah, I get 66 is equal to 3 times n minus 1. Divide off the 3, I get 22 is n minus 1. And so 23 is n. What's negative 8 plus 58? Not a trick question. Negative 8 plus 58 is 50. Divided by 2 is 25. And 23 times 25 is 575. That's the sum. If you take negative 8 plus negative 5 plus negative 2 plus 1 all the way up to 58, you get 575. What I would like you to do now is try letter D on your own, on your very own. Go. $873 divided by 9. What'd you get? So n is 98. So the sum of the first 98 terms is 98 times 9 plus 882 divided by 2. And what'd you get? 43,000? Sweet. We just built rockets today. We don't launch till Thursday, and it will be epic. Okay, we move on to partial sums of geometric series. Partial sums of geometric series. There is your formula. Math majors. Okay, it says find the sum of the following geometric series. Well, first let's expand it and see exactly what it looks like, okay? Let's plug in 1, and we plug in 1, what do you get? 1, because you get 1 after the 0. Plus, what do we plug in next? 2. And 1/2 to the 2 minus 1 would be? Now, if you look at the formula, does the formula require that we know the first term? But do we have to know the last term? We don't have to know the last term for some of the geometric series. That's kind of nice. So let's just go to work. Looks like n is 9. Sum of the first 9 terms is, what's the first term? And we have 1 minus, what's r? It's half to the 9th power divided by 1 minus 1/2. Well, what's 1 minus 1/2? 1/2. Dividing by 1/2 is the same as multiplying by 2. So I have 2 times the numerator, and we 1/2 to the 9th. So I want to figure out what that is. If you want to use your calculator, go ahead. I'll show you how to do that. I'll go back in just a second. Okay, here we have it. We have 2 parentheses, 1 minus 1 divided by 2 raised to the 9th power. And you can see that as I get a decimal, but if you just press math and convert it to fraction, it'll make a nice form for you. Oh my gosh, forgive us YouTube. They have no idea what they're doing. Oh my goodness. All right. Letter B. Okay, first term. What is it? Nope. 6. Well, 2/3 to the 0 is 1 times 6 is 6. Let's do another one. Then I plug in 2, and I get 2/3 to the 1 is 2/3 times 6 is 4. And then 2/3 to the third power, or to the second power, is 4/9 times 6 is 24/9 or 8/3. And we don't need to know the last term here. So we have the sum of the first 6 terms is, what's your first term? Times, the top is 1 minus, what is our ratio? Yeah, you can see it's always just sitting right there. It's always your ratio. It's super easy to see. You're going to raise that to what power? 6 divided by 1 minus 2/3. What's 1 minus 2/3? 1/3. Divided by 1/3 is the same as multiplying by 3. So 3 times 6 is 18. So we have 18 times 1 minus 2/3 to the 6th power. And now we'll do that great option on your calculator that you guys didn't know how to do. Jeez. Oh man, you guys are unbelievable. There you go, 1330. I'm supposed to teach you AP calculus. Oh, 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 well, way to take one for the team. And she said I could drop the class. Oh, okay, you got it. All right. All right, I know you blocked my voice out. Okay, here we go. I will do one more together. What's different about letter C? Okay, we have to find the ratio. What's the ratio? Divided by 2 or multiplied by a half. Good. So if I'm multiplying by a half, I also need to know the term the term number. What's how many terms do I have? We don't know, do we? So you have the sum of n terms is going to be the first term 10 times 1 minus r to the, or r is 1/2 to the nth power, all divided by 1 minus a half. So we need to find n, don't we? Well, let's use our rule for geometric sequence. A sub n is equal to a sub 1 times r to the n minus 1. So we'll use that to find n. What is our term that we're trying to find? 5/32 is equal to first term times ratio is 1/2 to the n minus 1. I have to solve for n. How would you like to do that? Divide by 10. 5/10 is 1/2, so I get 1/64 is equal to 1/2 to the n minus 1. Oh no, the variable's in the exponent. How do we solve things when variables are in the exponents? Logarithms. How do I get rid of the 1/2? I take a log base. Log base 1/2. What did you have as a teacher first semester, folks? Come on. I'd put in a complaint. That guy let you down big time. Okay, so if you got log base 1/2 of 1/2 to the n minus 1 power, you know that logarithms and exponential bases are inverses of each other. And so therefore, they go away. I'm left with n minus 1. Okay? And then how did we calculate that on our calculator? Log of 1 divided by 64 divided by log of 1 divided by 2. And you can see that you get 6. So add the 1 and you get. So now we finally know what n is. N is 7. Let's go and make use of that. Well, you could say 1/64 is 2 to the negative 5th power, right? Or negative 6th power, okay? And then this is going to be to the negative, so 2 to the 1 minus n. You could do that. So now you have negative 6 is equal to 1 minus n and solve that way. So you could do it without a calculator. Use your calculator. All right, so here we go. What is n? 7. So 1 minus 1/2 is 1/2, and divided by the 1/2 is the same as multiplying by. So I get 20 times 1 minus 1/2 raised to the 7th power. So I'll take my calculator. I'll use my fancy-dancy fraction operation. 1 minus 1 divided by 2 raised to the 7th. Get a nasty decimal, but thank goodness for that. 635 over 32. All right, flip it over. Last part. Remember, you have a full work day tomorrow, folks. All right, are you ready for the proof? Thank you. Rachel's ready. Let's go. If I have a sub n is equal to a sub 1 times r to the n minus 1, that's a geometric sequence, correct? I would like to find the sum of an infinite number of those geometric sequences of terms, okay? So here we go. Let's figure out the first term. The sum is equal to, what would the first term be? Plug in 1 for n, and what would you come up with? You'd come up with r to the 0, which is 1, times a sub 1 is a sub 1. Good. Plus, now we'll plug in 2, and you'd get? You get a sub 1 times r to the first. And then you get a sub 1 times r to the, and you get a sub 1 times r to the, and that will just continue on and on and on, right? Forever. Infinite grouping. Now, we'll see if you can follow this piece. This is all you have to do is just follow this basic piece here. I'm going to take the sum is, I'm going to write the a sub 1, but I'm going to factor an r out of the rest. If I factor an r out of the rest, what's left here? And then what would be next if I had a term there? Right? Okay, good. Let's see if you can see it. Look at this. A sub 1, a sub 1r, a sub 1r squared, a sub 1r cubed. Isn't this thing in parentheses the same as that? And what is this equal to? S. That thing is S. I'm trying to solve for the sum. If I want to solve for S, what can I do to this side? Factor out an S. What are you left with? So it sounds rather ridiculous. I know for some of you that was a little fast. You're still wondering how the heck did that happen. Watch the video tonight. The sum of an infinite geometric series is a sub 1 divided by 1 minus r. It is the easiest of all the formulas. So let's see how this develops. Look at your very first term here. We plug in 1. What do you get? You get 1. Let's plug in a couple more terms. Let's plug in 2. What do you get? A half. Plug in 3. Plug in 4. You get. Okay, and it goes on forever, right? Now think about it, folks. 1 plus a half is 1 1/2, right? Or 3 halves. Plus a fourth would be 7/4, right? Plus an eighth, be 15/8. We got 1, we got 3 halves, and then we got 7/4, 15/8. And then the next one would be over 16. It would be 31/16. Anybody know what this is going to add to? What are these numbers getting closer to? Yes, they are getting closer to the sum, which is, yeah, getting very close to 2. Let's try our formula. Sum is equal to, what's the first term? Divided by 1 minus r. What's r? What's your ratio? What's 1 minus a half? What's 1 divided by a half? If you sum up an infinite number of those terms, you come up with 2. Now you start to wonder, well, how do you sum an infinite number of things? That's what calculus is all about. The word calculus comes from the idea to calculate the infinitely large and the infinitely small. Those two ideas make your brain explode. You're right. Infinity is not a real number. It is an expression for very large number. Okay? Our national debt would argue that. So national debt is proven to just defy all logic of large numbers. It'll just push through. The race to 1 quadrillion is on. Year 2067. We will be there, and I'll be alive to see it. Oh, you wait. We'll get there. Okay. All right. Let's plug in 1. Plug in 1. What do you get? 6. Plug in 2. 4. Plug in 3. You've seen this one before. Okay. So the sum is equal to the first term, which is divided by 1 minus, what is the ratio? It is 2/3. What's 1 minus 2/3? 1 minus 2/3 is 1/3, and 6 divided by 1/3 is? Does that have a common ratio? 1/3. What's the first term? What's 1 minus 1/3? 12 divided by 2/3 is the same as 12 multiplied by? Does that make sense? Like 12 plus 4 is 16, plus 1 1/3 is 17.3 repeating, and then plus 0.44 would be 17.777. Seems like it's getting closer to 18, right? Let's do the next one. Sum is, what's first term? Divided by 1 minus, what's the ratio? 2, and I get 3 over, so -3. Let's think about it, folks, okay? Let's think about it, okay? What would the next term here be? 24. And after 24, then 48. I mean, the numbers continue to get bigger, right? It does. It goes to infinity. So here's the deal. Only if the absolute value of r is less than 1. If the absolute value of r is greater than 1, then it diverges. It converges, or meaning it goes to a single number if the absolute value of r is less than 1. If the absolute value of r is greater than 1, then it diverges, meaning it goes to possibly positive infinity or negative infinity. It's obvious to see in this situation that since the r value is greater than 1, it's 2. You can see in this scenario, it goes to infinity. Okay? And so therefore, our summation rule doesn't really work out. It's infinity. Totally cool, huh? Sum of infinite series? I mean, that's just good stuff. Elena, how do you feel about it? You feel like you're going to get a homework assignment? How about this? How about I don't give you one tomorrow? No, this is just one is arithmetic and one's geometric. So make it happen, folks.